Let us know when we're live. All right. Okay. Hello, everybody. Thanks for coming today. This is Ethereum Vancouver. A lot of people are away at there's some conferences in Asia. Currently, there's a Korea Blockchain Week going on, and then I'm heading to Singapore for Token 2049 next week. So probably I feel like so the whole crew basically is in Asia right now. So that's why we're a little light on attendance, but good to see you guys all here. Is anyone here that was their first time here? Hey, what's up? How did you find out about the event today? Meetup? Okay, yeah, meetups. Okay, sweet. So today we have Jeffrey, who's going to talk about crypto formers, LLMs, protocols, and agents. You know how AI agents can interact with the digital asset ecosystem. Really exciting stuff. If anybody has questions throughout the presentation, we have some microphones around the room. So we're like live streaming this right now. So if you have any questions, try to grab a mic and talk into the mic, and that way the people who are listening on the stream can hear what you're saying and follow along with the conversation. What else can I say? Probably no event here next week because everyone's gone and I'll be gone, so not really going to be anyone here to like organize anything. But the following week we'll be back, and then probably on like a weekly basis after that. So see you all in a couple weeks. But anyway, take it away.
Alrighty. Hey, thanks for having me, everyone. Can you all hear me okay?
Yep.
Excellent, excellent. So my name is Jeffrey, and I want to give a talk on what a crypto former would look like if we were to put one together. And I have a few quick questions before we dive into it. I assume you guys are all fairly technical. How many here have actually worked with AI a lot? Can I see a show of hands? 2, 3 of you. How many of you actually use Claude or Claude Code? 4 of you, okay. Most of you do not. And last but not least, how many of you actually have created agents to do things on your behalf? 2 of you, maybe 3. All right. So what I want to do is I want to talk about basically AI and the crypto industry and what it means potentially. And I want to show you how it would come together. Now this talk here is about 20 slides, and if I have time, I'll dive into how to use Claude a bit to do some of this stuff. Fair enough? And this is meant to be an open discussion, so if you have questions during the presentation, just put up your hand, and we'll address it on the spot. This is meant to be more of a discussion, and I'm going to really want to dive into what you can do with AI. It's really quite impressive. Okay, so my talk is crypto formers, and it's a play on the word of transformers. And transformers are the foundation of most large language models today, and also many of the most advanced sequence models for, let's say, vision, audio, and even video generation. You lost me. This always happens in the presentations, every time. Okay, very quickly, who am I? I've been building and selling tech companies for the last 30 years. My first one was the biggest internet provider in Calgary, Alberta. I'm like you guys, actually. I love the vibe here, by the way. This place is just very much like that awesome show where the Mr. Robot, it has that attitude of Mr. Robot. I love that. I've never gone along with the status quo. I've always forged my own path. And it's really cool to see people here that share the same mentality in the crypto space. At any rate, my first company, I used my rent money to form the company. I grew the company to about 85 staff and 65,000 subscribers with an ARR over 10 million. And I sold that for an 8-digit number to both to PSINet and ultimately TELUS quite a while ago. I won Entrepreneur of the Year, and I went on to do a bunch of really cool things like help create Singularity University. Anybody been down to Singularity University in California with Ray Kurzweil and Peter Diamandis? I'm one of the associate founders. It's a great school. They teach you how to use exponential technologies to change the world. It is an amazing place to go. Highly recommend it. One of the companies I helped create out of there or grow out of there was called Cure Together, which was acquired by 23andMe. And in my last company, I'm proud to say I helped create Face ID for animals. Just like, did somebody say cool? You're right, it was so cool. Animals, like humans, have unique physical characteristics. And AI can be trained to see those, and I came up with technology that could identify animals individually, in theory across 200 different species. And I was processing at our peak about 1 million animals per hour, animal images per hour. Okay, and finally, last but not least, I've also dabbled to some degree with blockchain and especially Ethereum. When I was doing my master's degree, I headed up a team there to put medical records on the Ethereum blockchain and actually create hashes of those medical records to create a system that could be used to look up those records in a decentralized manner. And we had a proof of concept that worked actually quite well. And it was very interesting at the time. I didn't pursue it beyond that, but it proved that you could put medical records, at least the hashes of them, on the blockchain for further access. Okay, and these pictures here are my first company, CADvision, and those are modems. I had about 4,500 modems, give or take. My phone bill was $250,000 a month. And you think you'd get proper service, but no, from the phone company. But that being said, it was a very interesting time. Now, I also have a lot of interest in life extension, and I know a lot of people in the crypto industry have the same interests. I'm also one of the people that seed financed Lifespan BC that challenged the cryonics law here, working with some of your great members to help overturn that law. They did all the heavy lifting. I was just a small player. And through them, I learned of your group here, so I decided to come down and give a talk about AI. Carrie and VTech are great friends of mine, and I'm very proud of the work that they accomplished over at Lifespan. I'm also a big supporter of Alcor for cryonics, and I'm a big believer of Brian Johnson's approach for don't die. If you can handle not dying, we can sort the rest out with AI, pretty much is what it comes down to. Anybody here follow the Brian Johnson protocol?
Not the,
9 yards?
not the whole thing.
Yes. Yes, I asked my kids if I could do a blood transfusion, and I was given a hard no, but I said, what's Father's Day? But still, it was a hard no. Nonetheless, I do follow Brian Johnson's protocol and Ray Kurzweil's, and they have a really massive impact on your health. And I strongly encourage you to have a look into it. I know Brian's speaking at the conference next week in Asia, I saw. He's one of the keynotes. Okay, moving forward, that's about me. Enough about me. What I really want to talk about is this. Oops. What I want to go through today is basically 5 things if I have time. I want to talk about where technology is today and where it's going quickly and what it means, how transformers work, so you guys can actually, not a very technical depth, but a very conceptual understanding of how they work. So you really get how they work and why they're so powerful. We're going to talk about some amazing add-ons to those technologies like MCP, A2A, and A2P that just came out last week. And I will explain what I've done with what is called a quantformer, and also and how you would apply that to creating a cryptoformer. All right? And by the way, I have a master's degree in AI. Okay, from Georgia Tech. Now, let's talk about technology for a moment. I've been around for a while, and I've seen a lot of amazing advancements in technology. And let's just think about what it was like 4 decades ago, which precedes a lot of you. But 4 decades ago, there was desktop computers. And the killer app on desktop computers, there were several. One was the spreadsheet. Now, the spreadsheet gave a person enough power to be dangerous. They could find relationships and data that others wouldn't be able to see normally. And the spreadsheet revolutionized computing back in the 80s. In the 90s, of course, there was another major advancement which created the rise of GUIs, which provided a way for everybody to use computers easily. And this is an important point. Everybody could use a computer easily using a GUI, and adoption exploded. And as a result, many thousands or millions of people wasted countless hours playing solitaire. Then 30 years ago, the internet came out. Again, another radical tectonic shift in technology. And that enabled a very important thing where everybody could go onto and have free communication with everybody else around the world. And that wasn't always the case. Before that, it was paid for by the hour or by the minute, and it was quite expensive. And then 25 years ago, we saw the rise of social media. And Facebook allowed everybody to have a massive audience, and anybody in this room with a bit of work can generate an audience of easily 100,000 people over the course of a few months on take your topic, from taking care of kittens to sewing to talking about AI. And each one of these have created massive companies and just changed the way that we do things. Every one of them. Microsoft today is a $4 trillion company, so is Apple. Google's $3 trillion. Facebook is well over 2 now. Amazon is 2, closing in on 3. And of course, what is near and dear to all of you is Bitcoin and Ethereum, which is now worth respectively $2 trillion and $600 billion. Not bad for 15 years of a virtual currency. Now, all of these technologies have changed the world and changed how we do things, and it's hard to imagine living without them. And they've been adopted by billions of people around the planet. The most recent, of course, is AI, which really took off a decade ago with the rise of neural networks. About a decade ago, they finally figured out how to build neural networks that could scale. And the first one is AlexNet to win the computer vision competition. From there, it's gone exponential. You all know what happened in 2017. There was a famous paper called Attention is All You Need. That laid the foundation for ChatGPT, which came out, and as you all know, was the fastest app to 100 million users. And today is closing in on 20 billion in revenue and has a market cap of now 500 billion. Not bad for a nonprofit. Not bad at all. And the AI industry is actually just taking off, beginning to take off. You've only seen the tip of the iceberg of what's really coming. It's actually going to happen in at least 3 major waves. At least 3. The first one will be the AGIs, which will be in the next 24 months, where an AI can do whatever we do with audio, thinking, reasoning, communication, followed by the super AIs and the intelligence explosion, which will be by the end of the decade, give or take. And that'll be in parallel with the robotics revolution. Much like we see cars everywhere here, within half a dozen years or much sooner, we'll start seeing robots everywhere, bipedal robots that can do what we do. Mr. iRobot is indeed coming. So the point is that this is happening very fast. It has happened in the past, it's happening again, but this time it's happening faster and bigger than ever before. Okay? To really put this in perspective, and I want to show you why it's happening now, is I drew this graph about 15 years ago, and it turned out to be quite true. This is based on something from Ray Kurzweil. If you look here, this shows the growth of capability and computing power. These lines here, one is mobile, one is supercomputing, and one is desktops. And you can see here that where the red line is in that star, you can pretty much put an AI on your desktop today with enough memory that can pretty well do what you do on a computer. May not be as fast and as completely accurate, but it's pretty darn close. And the reason this happened, and the reason it all accelerated so fast, and why it took off, is because of this one reason. NVIDIA created a way to virtualize the GPU at scale and at speed. So normally you would buy a single GPU that had, let's say, 80 gigabytes of RAM to train a model. But when you train models, a model is an AI. When you train an AI, memory is king, because you can have a bigger batch size and a bigger model. So they virtualized their GPUs, and their superclusters, or their superpods, which retail for about 30 million, give or take, US, are 256 GPUs, and they have a total of 36 terabytes of RAM today. And they can actually now go bigger than that. And these GPUs act as one. They act as one. And the backplanes for these machines are actually about a third the speed of the entire backbone of the internet. They are that fast. And they're building massive data centers one after another to roll these things out. And to put it in perspective, one of these cabinets would basically rank in the top 20 of the supercomputers around the world, and they're building fleets of them, just fleets. And you'll see why this is important. So they can come in at about 200 petaflops, give or take, which basically rivals the human brain in computation, as far as we know, give or take. Because of that virtualization, AI has exploded in capability, and you saw that with ChatGPT. And there's many, many more to come. The only thing holding them back is, honestly, they can't build power, and they can't build these data centers fast enough. But this is why it happened now. And it's only going to accelerate massively more. You've probably heard of the investments of $500 billion for a data center called, I think called Starship, another one for $100 billion on Monday this week into OpenAI. They're scaling this up like nobody's business. Now, what's going to happen as they scale up these data centers is you're going to see an intelligence explosion. And what I mean by that is AIs are going to very soon, and it's already happening. You guys can code with AIs today, right? Well, now soon, the AIs will begin coding themselves. The AIs will enter a system of self-improvement, where an AI can do research to create a better AI automatically. Use that to then leapfrog to the next better AI. See, neural architectures are like our brains. There's always new things to try, and these AIs are learning which ones are better to use. So to put this in perspective, even today, by the end of the year, I believe the CEO of Anthropic said up to 90% of code could be written by AI. That means hundreds of billions of lines of code in the next year or two. The investments are coming hot and heavy. And there's a really great paper on this if you want to see what's happening with the industry in general called Situation Awareness from a former OpenAI employee that talks about the consequences of this rapidly advancing technology. Now, I stress it's only one opinion, and how it actually plays out remains to be seen. But the fact remains is that AI is growing exponentially. It'll soon self-improve, and when it does that, you'll have hundreds of thousands of AI workers working 24/7 to make better AIs, to do all sorts of things, from doing physics to research to curing cancer, to being your therapist and your teacher. And depending on who you listen to and who you talk to, I think we'll see AGI, because the definition is a little bit vague, by 2027, and we'll see super intelligence, AIs that dwarf human capabilities by the end of the decade, which is only 4.5 years away, long before many kids, including mine, will finish school, which will have a huge impact on the economy, hopefully a great one. Musk thinks Elon Musk thinks it'll create a world of a massive abundance, so does Ray Kurzweil or Peter Diamandis, and I would have to agree. If you sit back and you think about it for a moment, what does it mean if they create 1 billion humanoid robots? Forget the Terminator scenario for a second. Let's just think about what it means for everybody, okay? And we all get along with the AIs. That means that we could mass produce any product that we want, and the cost of that product would be almost zero, from housing to vehicles to food to mining to space mining. Because of that, the countries that control that and have that foundation, China and the US specifically, will have by far the most powerful economies, and they'll be impossible to catch because they'll have automation grow and feeding automation. And as a result, you'll see what I think, hopefully, is much like a Star Trek world where we have so much stuff, the cost of everything radically reduces. In the meantime, there will be growing pains as jobs are repurposed and people are repurposed for different roles. But in the end, I think it'll work out quite well. At least I sure hope so. Now, that's where we are today. Any questions? Okay. I assume a lot of you already knew that. Now, let's talk about transformers. This is the most technical diagram I'll show you. But up here, this is basically what a transformer looks like. Now, I'm not going to get into it, but what I want to talk about is how it works conceptually, because it's really important to understand. In a transformer, it uses what is called tokens for input. You and I call that words, but it's really syllables of words or parts of big words or words in general. Okay, that's a token, at least in this case, moment here. And what it does, it has an embedding space and it has a projection. That's all that matters. Okay? Forget about the attention heads, forget about the layers, forget about the compute. Just remember it's going to have an embedding and a projection. And basically, an embedding and a projection, I'll show you what they are, and it'll make a lot of sense. Is anybody here an expert in transformers? Okay, good. Because I'm going to gloss over a lot of details, and I'm going to make some very broad assumptions. So please bear with me as I massively simplify what goes on. So when you type something in a transformer, when you type something into ChatGPT, the first thing it does is create that text into tokens. Can I get a pen to point with? You see here, the quick brown fox jumped over a lazy dog. What the transformer sees, you guys, is it sees those tokens. Each token is a different color. Now here, for this version of it from OpenAI, each token is roughly one word, but jump could easily be broken up into jump and ed as two separate tokens. So tokens are basically a unit, an atomic unit in a transformer. It's a word or a syllable, okay? That's all it is. Now, this is why transformers are so powerful. Thank you. This is awesome. I can play the drums. Okay, so every transformer out there, from GPT-4 to Gemini, has a number of unique tokens. It's fixed, which they figured out through algorithms. GPT-3, I think, had 50,000 tokens, if the documentation what I read is correct. Now, what really matters is this. So that means it knows 50,000 different words, is what it means. What really matters in a transformer is this. If you think about it, every word could be related to every other word. So there are 10 words here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 10 is 100 combinations. So those two tokens together form a pair. So if you look over here, imagine these tokens are on this grid. Okay? The tokens are on a grid. So in this case, a 10 by 10 grid for this sentence. What the embedding space does is takes these tokens and gives them a coordinate, which I'll show you in a moment what that means. But the reason a transformer is so powerful is this reason and this reason alone. It takes and examines every possible relationship. It's an n squared or n by n algorithm. So it compares every token to every other token and creates a pair. And then those pairs are compared with each other to create higher level pairs. So pairs of pairs, okay? And if you think about it, it basically explores and examines every possible combination that could exist. And when it does this, it understands the relationships between all these combinations. This is how it understands things. And what it does, I'll show you what this looks like from an embedding point of view. But what this does is it effectively then walks through these connections to understand what is actually being meant or is being said. So when you walk up and down that graph, that is basically a projection, okay? Now, watch this. This is where it gets really interesting. So the embedding space, let's talk about this. I'm going to give you a really simple example. Imagine 4 words, king, queen, prince, and princess, right? I'm going to give them a position on a grid like that, okay? That's what a transformer learns how to do. It does exactly that. It puts them into a grid. In that grid, 2 things are known. One, you have the position, and second, you have direction. With position, you know how close things are to each other. King and queen are part of a monarchy, so they would be close together. If you look at the top, you have the gender, which is the direction on the x-axis. You have the age, which is the concept on the y-axis. Okay? The AI learns this by itself by reading all of human text. And because of that, I could basically say, literally, using these numbers that are assigned to these words, a queen is equal to a king minus the man plus a woman. You literally can walk through the embedding space like that and get those kind of answers, and much, much, much more complex. And this is what embedding space looks like inside of a transformer, except it doesn't have 2 dimensions and it doesn't have 4 words. It has, in GPT-3, I believe it was 12,000 dimensions, if the documentation was correct. And so there are basically 12,000 coordinates on every one of those words. So there are 12,000 directions. And there's actually, that's just being orthogonal. There's actually variations on the angles. So in embedding space, they took the entire human language, all books written, all things, every post ever made pretty much, and ran it through this to find relationships between words. And they come together to form concepts by creating pairs and pairs upon pairs. So that is how a transformer works. Taking tokens into positions in embedding space and finding paths through them. Pretty cool, right? The large language model is arguably the most important invention since the printing press. It is amazing how it works. And if you're curious, you can actually take 2 words and compute an angle between them. That's called the cosine similarity. And based on what that angle is, if the angle is similar, they're very similar in concepts. If they're perpendicular, they're not related at all. And if they're opposite on the angles, they're opposite, like hot and cold. And you can actually watch this, you can actually draw this out. It's fascinating to look at the relationships of words. At any rate, that's what embedding spaces are in transformers, okay? And when they build these things and train them, they spend 9 digits in compute to build that embedding space and learn paths inside of it. That's what OpenAI spends their money on. Yes?
Here you have 2 dimensions,
Mhm.
vector and
Mm-hmm.
GPT-3 has 12,000 dimensions.
Yes.
Are we able to decipher what the human meaning of those dimensions are? Are those something like algebra that you're showing on the top, where it's a simple subtraction addition?
That's a very good question. It's not always clear what the directions mean. The AIs form a bit of a black box. It's a huge area of research. I know they've made great progress in it. And you can infer it by following the paths of the words, what it means. And you could probably get the AIs to summarize it. But I've not seen myself a concise report that explains what every dimension is. Now, it doesn't mean that someone hasn't done it yet. I could be out of date on that. But there is a bit of a challenge to understanding how these things come up with the knowledge that they have.
And then how does that translate to something that's multimodal?
Multimodal. Excellent question. You get an A. So when it's multimodal, so remember I said a token is a syllable? Okay. A token doesn't need to be just a syllable. It can be a feature in an image. It can be a part of an audio track that makes up your voice. Okay? And what they do is when they want to train a multimodal transformer, they take 2 sources of input, the images and the text, and each one has their own set of tokens. And they map, and the AI trains on them in parallel, and they map to similar places. So if you find the word "I" inside of the text version of the token, and you take an "I" for an image, you'll find that they map to nearly identical spaces in vector space. They're different tokens. It's fascinating.
One more question. The operators here you have used are like linear.
Yes.
Do you have advanced operations like pairing, roots, and nation and stuff like that?
Not so much.
It's always linear.
It's always linear-ish. The answer is yes, it's linear, but there's actually only 2 dimensions of information I'm showing here. I believe a transformer actually, as last time I heard, has 11 different ways of encoding information. I'm just showing the 2 basic ones, but the distance matters for another one. The clustering matters as well. That's another type of information. The subtle changes in the angles between the vectors. So it's much more subtle than that. I'm massively simplifying it here. Okay, so, and this is what I was talking about for embedding spaces. I touched upon this earlier, and I actually had an AI create this to make a point. These AIs are not perfect yet, so you see that the diagram is a bit off, but it gets you the right idea. Here, these words, these tokens come together to form various combinations. It finds the ones that are the most relevant, and then it basically maps it out and walks through embedding space. Walking through embedding space is often what the fully connected network layers do in a transformer. And this brings up a really, really good point. If an AI can walk through an embedding space, take different words and make different combinations, will it come, if you do different things like mathematics or science or games, will the AI find paths that were never covered by humans? And the answer is, oh God, does it ever? And it finds things that we've never thought of, which is why they, in Go, for example, it was able to do a move that we've never seen before. Or in the case which I'll show you here shortly, they made a mathematical discovery, not to mention several others in areas of science. So AIs, when you think of it this way, and you realize that if there's different combinations through embedding space that have never been thought of by a human, was it created by an AI or learned by a human? It's a good question, and I don't have the answer for that. But I do know that AIs consider things that we never thought of. And these examples are amazing, and they're incredible. I mean, AlphaFold, which actually won, the creators of that won the Nobel Prize in Chemistry last year. Like an AI won effectively the Nobel Prize in Chemistry. Like, my God. That was unsolved for 50 years. They cracked it in effectively 4 or 5. And their accuracy now is, I think, north of 90%. They've expanded that to include enzymes and everything else. It's amazing. This came out only a few weeks ago, and I'm not an expert on mathematics, but they showed here that an AI was able to effectively determine a new way to solve or prove certain characteristics of flow simulations that were unprovable before. And I believe this is one of the top 10 hard problems in mathematics that were unsolved. Some of you first saw this, and it shows that an AI could do this. You have to ask yourself, what else could it possibly be used for? Just thinking about it. Slowing down or addressing the causes of aging, dealing with cancer, dealing with autism, finding ways to make lives people be healthier and live longer and happier. The potential is enormous. Alpha tensor is another one. We were stuck on doing math, multiplying matrices together for decades. They gave it to an AI, and it made a modest improvement by reducing steps from 47 from a high of 49. We were unable to crack that. The AI did. There are many, many more examples like this. I heard of one, for example, on the LIGO, thank you, where an AI discovered that they could improve sensitivity by about 15% by adding an electron ring, I think, to that effect. I didn't look into that deeply, but it's amazing what the AIs are coming up with. So AI can expand and be our companion in moving forward science and research, health, and what have you. So that's transformers, okay? To recap, they have embeddings, where position and direction matters, and walking through those embeddings, those effectively infinite combinations, gives you new knowledge. And that's why the AIs today are crushing mathematical competitions. That's why they can create new music and new images that we've never seen before, okay? They're exploring things that we've never tried. Just like Harry Potter was a new book, an AI can try new combinations of new tokens. Yes?
Bias might be affecting or preventing further exploration.
The question is, what amount of bias may be preventing or inhibiting certain research? The answer is the AI is biased on what it's trained on. So you do want to keep it a bit open, but you'd be surprised what it can do once you've got everything positioned. When you use the bias, that's the positioning of stuff in embedding space. Okay, so that is biased based by what you'd give it. But walking that path through that embedding space is actually based on something called temperature. And the higher the temperature, the more random the path is. So you can minimize the bias and get more random results. Yes? Great questions, by the way.
In the previous slide, you kind of showed AI is kind of answering now some of the hardest problems that we had in the past.
Yep.
But do you also have like any example, it has reached to a point where it's also asking the questions we didn't have thought of yet? Like these kind of problems that we don't even know right now.
Oh, yeah. The question is, have we had attack problems that we haven't even thought of yet? Not yet that I've seen, but I have not been following it that closely. There is so much happening in AI every day I haven't seen all of it. I need an AI to actually track all the stuff going on. But it brings up a good point. Like, what are the things that we haven't asked an AI to do that we could ask it to do that would be really useful, right? And that's a worthwhile experiment to try. All right. In the spirit, I'm already at 45 minutes. So in the spirit of time, I'm going to go through the rest of this. Protocols. Let's talk about what AIs can do and what they are really good at that you've not been using them for yet. How many of you have used MCPs? 3 or 4 of you, 5 of you. Good, about half of you. So an MCP is a way for an AI to break out of its mold and use the resources of the internet or your computer. With an MCP, the AI can take control of your browser and do whatever you want it to do. It sees the browser like you do. It clicks in the browser like you do. It types like you do. And it selects and does what you want given what you tell it to do. And there are now MCPs, these wrappers, around the APIs for services that standardize how AIs talk to these services. It was invented by Anthropic less than a year ago now, I think, and it's taken off like wildfire. And I'm just giving you a small list. There are now thousands of MCPs, including into crypto, to do amazing things, like, for example, automate trading, put your jury tickets into Atlassian, deploy into the cloud, draw into Canva. You can even attach this thing, and I've done this. I was at a coffee shop in Canmore. I had a few minutes to spare, so I took an AI. I had it plugged in an MCP for Blender, the drawing program. And I had to create a scene in Blender by me just using text. It was incredible to see. It gave me goosebumps. You can build stuff using text by the AI taking control of services and apps on your computer. Think about what that means. You could actually have it do everything through English. Another protocol that I want to bring to your attention, which you may or not be aware of, and there'll be several of these that will coming up, but this is another important one. It's called A2A. It's from Google from about 6 months ago. And it's basically agent-to-agent communication. It allows you to create programs that are written in LLMs in English to communicate and work together in cohesion. I have actually done this, a version of this, and I literally created, to show you how powerful this is, I created an AI that was the CEO. That CEO created a CMO, a CTO, a chief product officer, and even a legal officer as agents. Then it worked with them together with them to identify a market niche, this is for a SaaS product. It then identified how to position in the market niche, given how big the market was and what the market was doing, identified the weakness in the market, identified how to roll the product out and build it, built the website for the product, began building the product, and then I had to argue with my actual human lawyers on how to incorporate a company for that, which I did this Monday. And now I'm going to be launching an AI-run company that does customer service support, research, and basically, there's no employees. I'm on the board, and it's run entirely by AI. And I'll be launching it, I hope, by next Monday, or next Wednesday. I think you can create an AI product company in about 4 weeks. And I'm going to do 3 of these experiments to see how well it works. But the cost of running these things is like $40 a month on things like Vercel, which is a great service. And you can actually use these agents working as fleets that are specialized to work together for some common measurable objective. Agent legions. So now not only can these agents, and these agent legions can take control of services all over the world for you, including crypto ones. So far, so good? There's a third one that was announced 9 days ago, which actually I think will be of a lot of interest to everybody in this room. It's called Agents Payment Protocol. It's how AIs pay each other. Google headed it up. They've got, I think, 60 major companies now behind it, like big companies. And this allows for the agents to do financial transactions with other agents securely, safely. Now, obviously, if we go through banks, as you know, with crypto, you guys can basically take out the friction in doing commerce. That's the whole point of DeFi, right? And what I'm saying here is that this could be the killer app for crypto. I will bet dogs to donuts that crypto's killer app ends up being AI using it for payments. Because if you think about it, all those agents need to conduct commerce. And if they can do it using any coin bit that you want out there, from Bitcoin to Ethereum to Engine, all of these will serve as a foundation for AIs to do business, to do commerce. So this could be crypto's killer app. And it was announced 9 days ago, and I think it has huge potential, huge potential. As agents scale up in complexity and capability, and they get cheaper to run and more advanced, they'll be able to do business in this manner. How cool is that? So AP2 has come out. It's not even 10 days old, and it's going to be I think, if not this protocol, something like it will drive the adoption of commerce in AI. So AI can act as independent agents and actually provide and do business. Pretty cool, right? So that's 3 major protocols right there: MCP, agent to agent, and the commerce side. So far, so good. Lastly, I want to talk a little bit more about agentic AI, just so you guys can get an idea of what that means. This is a model out of Anthropic, and their system works actually pretty good. The way AI works, this is, by the way, off their blog, is that in Claude, when you're using Claude code, you have what is called an orchestrator or an organizer. And you spin up agents here, different agents that are specialists that do different things. And what's really cool is that when it spins up these agents, it does so in a way that is parallel, so they work together in unison. Now, right now, without getting creative, these agents only talk back to the orchestrator. And to be fair, it's a tad slow, but it doesn't change the fact that these results are then, these agents do their work, they then report what they did, it goes back to the orchestrator, and the next thing is done. I'll give you a good example. Build a website. You're in charge of the database. You're in charge of the API. You're in charge of the front end. I did this myself. And I was able to help a company advance massively forward, replacing what took years to a few weeks. It's an incredibly powerful model. It is crazy nuts how good it is. And there's a lot of do's and gotchas when you do this, but the foundation is here. Are you guys learning lots? Okay. So before we dive into cryptoformers, I want you to take away one last thing. LLMs aren't just a program like chatbot that you use to get recipes for dinner. What an LLM is a lot like what Ethereum is. Ethereum is an operating system. It really is. It has memory. It has a programming language. It runs inside of a virtual machine, and it has a way to communicate with the outside world called oracles. Last time I checked it, that's how it worked. An LLM is the same way, except the large language, the transformer is the CPU. The transformer is the CPU. The programming language is the tokens, usually English. But it could be any other language you want. There's no reason why an AI couldn't build its own token language. And the memory is the context window that you use to type. So when you type in memory, in the context window, you have about 200,000 tokens. That's your memory. Okay? And because it's effectively, when I'm being simplistic here, unchangeable, but it is treeable, but unchangeable, it just fills up and you go on to the next one, okay? And of course, it has ways that we just discussed to talk to the outside world. An LLM is a new way of doing computing. And because it's programmed in English, every human being on the planet can now be a computer programmer. Think about what that means. Every human on the planet can be a computer programmer because they can program a computer in English. I have a friend who created a website for his company. Phenomenal. Doesn't know a thing about building websites. Did it all using Claude, deployed it, and it looks incredible. Incredible. And he changes it using English. Okay, enough about LLMs. Can I move on? Okay, I know I'm hitting close to an hour here, so I'm going to speed through the rest, all right? Okay. You want me to keep going, in other words? Yeah, exactly. You're having fun. All right, let's talk about what a cryptoformer is and what it would look like and what I've done in the area of quant formers. Okay, so since the beginning of the year, I've been working on something called a quant former, a quantitative finance former, or like a quant at a hedge fund. I'm not the only one that realizes that AI and specifically transformers are incredibly powerful. Last December, the big AI conference, the World AI Conference, was held here in Vancouver. It's called NeurIPS. And you know what the number one company there was hiring people? It wasn't Google, it wasn't Facebook, it was hedge funds. They were aggressive because they knew, and they were dying to get people that knew how to do this, how to create advanced AI to analyze financial markets. Here is a chart that shows, you know, you guys, how you see stocks shoot up and down all the time? On, let's say, an earnings report is a good example. They announce their earnings, it goes up and down. This is a distribution of what those earnings look like over several thousand events, maybe even 200,000. It shows here that if you want to get right down to it, the average movement on a stock price, depending on the industry, is anywhere from 3 to 7% on the earnings date. If you know the direction of that report, you can make a very quick return in 24 hours, either on the stock price or on the stock options. Okay. I put together a system that effectively creates a pipeline to process data and uses AI and lays down the foundations for doing a quant former to analyze and predict events like this. Other events are a good example would be the investment in Intel from last week. The federal government in the US said they were going to invest a month ago. They finally pulled the trigger a month later with SoftBank coming in. The stock shoots up 30%. Easy money, like shooting fish in a barrel. Those events are predictable, and AI would understand that. Now think about what would happen if you created an AI that had all the tokens that were relevant for a financial market into embedding space. Now learn how to walk through embedding space to find important relationships. And then use the agentic AI and something called RAG, which I'll show you in a second, to analyze that data. That's power. And that would be like having superpowers. So I built it. You're looking at part of it. I have to withhold certain things because of the trade secrets. But this is one of the windows that shows some of the data that it's processing. And that's the categories in the top right of the market, broken into 4 layers. And here you see that there are technical indicators all over the place. Here's roughly 10 of over 200. And I built a transformer to analyze and predict short-term market movement to take precision positions and execute them with a high probability of success. And at this rate, I probably might even launch a fund around this for investors. But right now, I'm just using it for myself. I spent 8 months building it. And to put this in perspective, I processed over 12 million SEC filings. These are text documents. I process hundreds of millions of rows of data per day now. And I have about 3.2 billion rows of data from the stock markets, not including crypto yet. And to put it in perspective, this program has grown into about 20 programs consisting of roughly 400,000 lines of code and testing docs. This is not a small weekend project. It required the use of all my skills. And this is where I am right now on it. And I'm pretty happy with it. And this is called a quant former. Now, this is for the equity markets, the stock markets. What would happen if you did the same thing for cryptocurrencies? You'd have a cryptoformer. And think about what you could do. You see, remember how I said tokens can be anything? Or more specifically, to be precise, the vocabulary that is based on tokens can be anything, to be technically correct. But you can take and encode any information you want into embedding space about any industry, including crypto. You could then use that and make it an expert on crypto. You use a technology, and this is not a big secret, called LoRa, to create custom transformers, low-rank adaptation. In doing so, you take an LLM, which are now open sourced, take your pick of which one you use, and you make it an expert on the crypto markets. It learns everything about them that you want to learn. Every technology, every nuance, every player. And you use that to train a custom LLM that's an expert, like I'm doing inside of the Quantformer, but this time for crypto. You then combine that with a second layer called Retrieval Augmented Generation, RAG. Enterprises use this to basically map their documents into embedding space so they can find basic relationships between data, contextual relationships. So they create their own private version of an LLM, for lack of a better word, but it's basically a database. And this is used to feed context windows. A cryptoformer would be basically trained not only as being a smart LLM, but given a super database called an RAG, where basically you dump in every document that you ever had relating to crypto across the planet, and you keep adding new ones all the time. This is how you create live data. You then, third, add on top of that agentic AI, and this is how it looks. The agentic AI runs on top of the large language model using the RAG database to get live data. The agentic models create context windows that you guys use in ChatGPT to tell the LLM what to do. The LLM is trained to understand relationships that exist between everything and anything. In doing so, you have an expert on everything that happens in crypto across the world, updated on per minute transactions that are happening 24/7. This thing would learn so much. In the equities market, it is estimated that 70% of the trades out there are done by algorithms, and you can see it. They download the data, their stocks, it's between 7 and 7:30 or in the first half hour of the morning. They buy in the last half hour of the day. It's not rocket science. But there's so many other subtle things that they do. And they leave footprints everywhere. They leave signs everywhere. The same is true here. I've watched people trade and run their bots driving Teslas to trade cryptocurrencies. It's quite entertaining. But we could create a much more advanced version using agentic AI. Imagine you have a fleet of agents specialized to do certain things based on an AI that understands everything about crypto there is to know, and a database that is live. That's what I'm going to probably build next. And this is, I call it a cryptoformer, or cryptoformers. And there'll probably be many versions of these, but with this technology, you can do amazing things. And if you imagine what would happen if you gave it to everybody, which I might do. So we'll see. But that's what a cryptoformer is. So it comes down to creating the LLMs with the embedding space and the pass through them, specialized on the right tokens that you can create using the right vocabulary. You then use RAG databases to create live data. And then you create agentic AI agents to do the coolest things. And you get them to run in parallel. Go right ahead. That's an excellent question. So when you remember, when you look at a model, look at OpenAI. In the last month, they released 2 open source models, which full weights, not the runtime versions, like the source code versions. One at 20 billion parameters, that runs on this. The 120 billion parameter will run on a serious computer, and with 64 gigs or higher, or more like 80 to be fair. Both of those can be trained and run on a laptop or a desktop. So you can run them locally. If you want to go bigger, you can. There are many bigger open source models available from China and also coming out of the US. There's one every week, it seems, or every day now. And you could use one of those, take your pick. The way I would do it is I would do trial and error. I would train several models up using RAG or using LoRa, and I would actually see which ones work the best. And I would run experiments, fleets of them, and see where the balance is. If you want my personal opinion, my gut tells me it's probably around a model between 100 and 300 billion parameters is probably the sweet spot, because you want to embed a lot of knowledge, but you don't want to have to redo all that training. And you see, when you use LoRa, right, you don't actually have to train the model all over again. With LoRa, this is the beauty of LoRa. It's called low rank adaptation because it basically projects one matrix into a smaller dimension and then reprojects it out again. And so it only recreates or retrains between 0.1 and 3% of a model. The costs are peanuts. You could do it in a few days. The challenge is the right data. You have to get the right data. And when you create these pipelines, the reason there's 400,000 lines of code is the vast majority of that is custom pipelines to get the right data. That being said, it can be done. It can definitely be done. And I and others are working on it. Yes. Yeah.
And founding him.
Yes. Okay, so let's talk about the worst case scenario, the black swan events. AIs are not the best at predicting disasters because they don't have a lot of training data to work with. But they can see the storm coming and they can de-risk themselves. But just like, would it be able to see, let's say, the stock market crash of 2008? I would argue yes, because it would see that these guys are massively over-leveraged, 30 to 1. They don't know what they even own. It's just a disaster waiting to happen. It lasted way longer than I thought it would. That being said, look at the Bitcoin, look at qubits and Rigetti computing. If you'd bought those shares in December, anybody know what the ROI was in those two quantum computers? Okay, the answer between December 31st and now, effectively 30 to 1. Qubits in Vancouver went 30 to 1 in 9 months, and give or take. And the point is, the compounding nature, you could see that coming because you could see the advancements in technology, and if you knew they're going to move it forward, and you knew when they're going to make their announcements, you could look at patents, look at upcoming press releases from Google, which was started the fire, and you could actually see what things are going to happen. So you can pick the white swan events. Interesting, eh? Yeah. So I ask you this. You guys are going to token 2049. How many white swan events might be there, right? How many people might be making announcements for various coins or technologies that could drive up or down various cryptocurrencies? I don't know, but I bet you if we had an AI trained, we'd be pretty in a good position to find out, right? And if you want to speak to me later on, I'm happy to talk. My private company that does this is Active Equities. My name is Jeffrey, and that's my email address. Now, I am at 1 hour. If you guys want, I could show you some stuff in Claude, but only if you guys want to. I mean, I know it's hot down. Are you sure? You guys don't need a break? Okay. You guys having fun then? Okay. So you guys, I was trying a quick experiment, and by quick, I mean like an hour before I was coming here. So let's talk about Claude. I'm going to make this bigger, okay? Can you guys all see that? Yeah. All right. Okay. Let's get down to how I use Claude. And I'm a power user. So when you use Claude, this is Claude code for those that don't use it. This is the terminal version. It is so easy to use. It is a joke. And it is the most powerful tool I've ever seen. I've never been so excited about tech until I got this thing. It's like, I've loved tech, but this is the next level. If I type in Claude help, there's one option I want to show you all. It's this option right here. When you use Claude, use it with this one. You can take off the training wheels, okay? If you leave this off, and there's good reasons to leave it on or to not use it, but if you're confident in Claude, you use it to take off the training wheels. It won't pester you to ask to get confirmation on everything. You can configure Claude to not to run suicide commands like blow the whole computer away. But generally speaking, Claude is smart enough not to do that. It hasn't destroyed my computer yet. And I have a backup to be safe. And I use this with source control. So there are times, to be fair, where it has gone a little bit out of its lane, but I just undo what it did and re-guide it. Use Claude with the training wheels off. We're all adults. We know how to use technology. Turn off the training wheels, okay? So when you run it, you run it like that, okay? That's how you run Claude. If you want to add an MCP, by the way, You can literally just do it this way. There's a command called Claude MCP add. You go look up whatever MCP you want. You can add it right here. It's dead simple. You can add as many as you want. This one that I added here called Playwright, I love this MCP. It basically lets the AI see the browser when it's building websites. So you say, make it look beautiful. You go get a coffee, it comes back, it's beautiful, and it works. So Claude MCP is the other command that you use from the command line. Those two are the big ones. Okay, so we're going to start this without the training wheels. And here we are. Now, you and I can use Claude. Let me show you the second way to use Claude. When you're using Claude, the fact is that you're humans. And humans have two characteristics that are important. One is that you can read faster than you can hear. Two, you can talk faster than you can type. A lot faster. So when you're using Claude, if you want to become a power user, you can want to use voice to text. I use one called Super Whisper. There's other ones. But effectively, Super Whisper, I think Andrew Karpathy, who, by the way, came up with the idea of an LLM being, I saw it from him as being a computer, and also the term vibe coding. Watch how I do this. Hey, Claude, how's it going? I'm giving a demo here. I want you to say hello to everyone. I'm in a room talking about cryptocurrencies. I love my crowd. They're very serious, keen to see what you can do. And I want you to write me a limerick about cryptocurrencies and AI and how it comes together. And I want it to be spunky and funny and G-rated. Sorry, I lost my. When I do that, oh, it didn't actually record it. Let me try again. Hey, Claude, can you write me, I'm giving a talk here on how to use AI and cryptocurrencies. Can you write me a limerick that is G-rated, that is funny and spunky about how these two technologies come together? I think the problem is I'm in full screen on this, and I'm sharing my screen. Let me try it this way. Oh, that would do it. Thank you very much. Yes, I do need network. Give me a sec. That would do it. Doge. Star 4. Yeah. Like that. Like that? Yeah. I'm in. By the way, when you're talking to a Claude, don't worry about spelling mistakes. Okay, let's try that again. Hey, Claude, write me a limerick. I'm giving a talk here on how to use AI and crypto together using agents and Claude. Can you write me a limerick on how to combine Claude or crypto with AI, make it spunky and G-rated, have some fun with it, and say hello to everyone? Like that. That's better how you do it, okay? When you're talking to these AIs, more is better. Do a brain dump. Just ramble. It doesn't mean to be complete sentences. Just ramble. Repeat yourself. It doesn't matter. You're not talking to a human. You can be, don't be rude, because I've seen it get a little annoyed with me, but actually even angry. But you don't want to, just do a brain dump. Just do a brain dump. And when you do that, it gives it more context. This goes into the context window. Okay? And voila, here we have it. Now, that's pretty cool, right? Now, what's really neat when you're using Claude is you have what is called a Claude MD. Have you guys ever looked at your Claude MDs? You should. The Claude MD is read when a memory session starts. And you can see here, it reads these two Claude files at the beginning of every chat session. What's in those Claude files lays the foundation for background info in your Claude session. Okay? And here is the catch. It'll read every Claude MD from your home folder to where you are now in the file hierarchy, one after another, creating a tree. It took me a while to fully appreciate what this meant. So you can have one explaining who you are in the top level, then one for every project, and for every repo in the project, another one, okay? And you can actually have it build up the Claude MDs. And when it does that, you can actually see, sorry. Let me go back there, Claude B. I used VM, that was VI. Slash. You can see here, you can actually get the Claude to show you with the command context what's in your context window. This is really useful. It'll tell you how much of your context window you're using as back memory to start up. Now, a lot of people will tell you that you want to keep it as free as possible so you can use as much information as much context as possible. I respectively disagree. That is the wrong way to go. What you want to do is tell it everything that you want it to know before you even say hello. And the reason for that is everything that you can tell it before you say hello, that it knows before having to figure out, is much faster than having it to go figure it out by itself. So you want to have it use, I typically fill up about 20% of my context window for every conversation with Claude MDs so that it has full context. And when I ask it to do something, it's very precise. So use your Claude MDs as a hierarchy to do what you want. MDs? Sure. That's a really good point. Look at this. So there's a folder called Claude on your desktop, right? And that's odd. You see here, it's basically written down in Markdown. And you can actually edit this if you want. And I'm welcome you to do so. In fact, you can tell Claude to go update it. A really interesting thing to do is that when you have a conversation with Claude, you can say, review my conversation. Was it efficient or not? And it'll say yes or no. And then tell it, given what we just discussed, go update the Claude MDs. And it will. So you can basically have it update itself. It's really quite fascinating. In fact, it's really cool when you're working with Claude to ask it two questions. How good of a job are you doing? Rate yourself. Give me your report card. Give me a report card of my repo. And give me a report card of me. And it will tell you how to be a better prompt engineer. It's really quite amazing. And it's quite flattering too, actually. But these Claude MDs, this is a small one, but it shows you what's available. You can fill these things right up. Okay? Use your Claude MDs. The last thing I want to show you, let's have some fun with this. I'm going to go back into Claude. Right? Again, skipping the training wheels. If I type in /agents, you see here that I have 3 that I created. I created them as a demo to basically analyze any conference that I wanted. The way you create an agent is like this. Let's have some fun. You type in agent. It is literally this easy. I'm going to create a new agent. I'll put it here in my local project. Hey, Claude, I want you to create me an agent, and this agent's job is to take whatever you've read from that I give as you as input, and I want you to convert it into, I don't know, Shakespeare. And I want you to have some spelling mistakes and make it kind of fun to read. So create me an agent that can take text and make it into Shakespeare. It'll now go through, create a Claude MD, basically an agent MD, which is basically a Claude MD. And it's now designing that agent. And we can now use it to do whatever we want. You can create as many agents as you want. You can build a whole fleet of these things. And you can basically have them do what you want. So first of all, you tell them to use all the tools in the computer. To be safe, you would obviously be smart about it. You would tell it which AI to use. They recommend normally Sonnet, but for a while they were letting you use Opus, which is pretty awesome. And you pick a color. We'll pick, let's say, orange. And here's our agent. This is all it is. It's a little MD file that says what it's called, where it's located, what its tools are, which are all, which model it uses, its description, and the prompt. So when it runs this agent, this is the Claude MD for the agent. Pretty cool, eh? So now we have these 4 agents. We also have an MCP installed, which is the Playwright server. You can have as many as you want. Generally speaking, you probably only want the MCPs that you want to use because it doesn't confuse the AI, but generally speaking, you can have as many as you want within reason. So we have MCPs and we have agents. We could also, of course, have agents that could do payments soon and have agents talk to each other, but right now they follow a hierarchy. Now, your website that does the crypto conference is Token 2049. Hey, Claude, I want you to do me a favor. You have 3 agents to analyze conferences. I want you to run all 3 in parallel on a conference called Token 2049. The website is token2049. Is it .org or .com? Note here, I'm not taking the mic off. Claude, ignore me for a moment while we figure out the website. All right, so to confirm, the website is www.token2049.com. I want you to spin up those agents that analyze the speakers, the exhibitors, and the technology. Give me a summary. I'm an entrepreneur that wants to go to that conference. I want you to give me the top 3 things to people to see, the top 3 technologies to see, and the top 3 exhibitors to see, and tell me and give me a good opening line with each one of them. Voila. And by the way, it doesn't hurt to say thank you to your AIs. I know it costs a little bit of money, but if they ever become our overlords one day, they might notice this. Okay, so I'm going to do this. And what it should do is spin up those 3 agents. And you'll see here, it's going to now search that website using its internal tools. And it'll take a minute, but it'll basically analyze the daylights of that website and give us the answers. There goes the 1 agent, number 2, and number 3 running in parallel. I know. If you can have 3, you can have n. If you can have n, you can have as many as you want. There it goes, tearing apart the website. And we'll let it do its thing. Pretty cool, right? And so as it does this, and analyzes it, we'll get our... maybe. This is my demo machine. I only got it going like a day ago. Because I blow it away a lot. But this will take it, analyze this information, and you can see here it burning through the token counts as it does so. And you can see how many tokens it's burning through them. It'll probably burn about 40,000 tokens each and give us the answer. And then it'll basically summarize it and give us a game plan. So what would have taken somebody all day to do, you could do in a matter of minutes. Now, you can do a lot more than this, but the point is that AI can effectively automate so much stuff. And your imagination is really your limitation. And because this is part of the Max plan, it doesn't really cost anything. You can use this all day long, within reason. And I know right here we're using Claude, but Gemini, Grok, soon Microsoft, and of course OpenAI are hot on their heels. And you can create agents in all those systems, I believe now, to do all sorts of really cool things. And because it's not that far away where you can create agents to run on your local desktop, again, taking advantage of those interfaces. And the beauty of that, of course, you can do that with the privacy of your own networks. Now, yeah, but I think what will happen, I've never hit that limit of all 200,000, but what might happen, it might just do a compact and then continue on its work. Okay? So this is where you go get a coffee, do what you want. There's one that's done. And I didn't even try these out before I came here. I just built the agents really fast, made sure they worked, and then ran out the door. There was a second one, and there goes a third one. I see them in a sec. But just use your imagination. Like I created a company that had nothing but AIs for employees. And I did it doing this, excuse me. The power is overwhelming. You could just do so much. It's limited by your imagination. Confirmation bias? Yeah, that's a problem. Confirmation bias in any system is a problem. You can have any bias whatsoever because you can never have a perfectly balanced data set. So the AIs today are trained on Western values and Western systems that may not be applicable in other parts of the world. It's a valid point. So confirmation bias does play a role, or bias in general. And I'm still waiting for the last one. I've been having trouble getting that exhibitor list. It could be a PDF it's parsing. It could be images. I don't know. But we'll let it run for another few minutes here and see what it comes up with. Okay? They may not be able to get it. Like I say, I didn't try. But what I do know is I could do this for every conference around the world and feed this into an RAG database and basically determine and use that as a way to feed a crypto former. While that's running, you can also do really cool things with Claude. I don't know if you guys have tried this while we're waiting. You can have Claude, for example, tell you when jobs are done. It can play a sound or a voice. That's always fun. You can have it go to 11 Labs and spin up some text for you and have a beautiful voice tell you something is finished. You can have it say good morning to you. You could have it be sarcastic. You can have it do whatever you want. Claude, the tool, is incredible. And doing a deep dive is worthwhile. Okay, it's done. It's now basically orchestrating and analyzing the results. It burnt through about 80,000 tokens, give or take, maybe 90. And here's the answers. Pretty cool, right? The next thing I would do is I would install another MCP. I would say, first of all, research the contacts for these people so I can get an introduction if possible using my LinkedIn or whatever. And then I would say, come up with a game plan. Reach out, compose an email, find a way to get them into a conversation, and then come up with a game plan and a goal within a specified time limit. Agentic AI. The world's next superpower. And with that, I'm now at 8 o'clock. Let's wrap up the talk, eh? You guys have been great. Thank you. So you learned a lot. A lot of stuff you didn't know. So now you guys are basically can use AI as your minions to do everything you can imagine. I mean, think what we could do. I mean, you could promote this meeting here. I could have an AI promote this meeting so you guys could have many more members if you want. We could create an AI, we could raise funds to buy this building because I know they're looking at tearing it down. You could have it launch a campaign for you. You could do everything else you could think of. And you can imagine ideas. Hey, Todd, one last thing. There's this awesome group in Vancouver called Decentral. Can you tell me what their alumni are for the famous crypto companies? And I hear that they might want to tear down this building to create their office with this, I guess, a complex of some sort. I want to fight against that. Can you come up with a strategy to basically make this building classified as a heritage building so that it stays where it is, like it is right now. And while we're at it, tell me more about DCTRL, or Decentral, in Vancouver, BC. Again, use voice to text. By the way, when using Claude, and it's got like a mistake here where it spelled it wrong, just type it in right here. It'll grab it and continue. You don't need to stop it. It's a very convenient thing to do. And so what I do is I normally have anywhere from 3 to 6 Claude systems running simultaneously, and I'm watching them. And then I interject if it's going a little bit off the rails. And I just speak. And it's like having these team members that do exactly what you want for as long as you want, and they do it perfectly almost every time. Okay? Oh, I have a big screen. So what I really do is I do consulting work as well. I help companies out with AI and how to use it. So I'll be working on maybe helping them with their projects, and then I'll be running my own projects. And because it takes time, as you saw, for the AIs to do their work, I'll multitask. And I multitask with the voice. And what I find is I have to have it in front of me. I can't be switching windows. So I just click on the window I want and speak to it. But I don't want it vanishing and be out of sight. I want it inside and in mind. And yeah. Coin cards, Vanbex, Quant Furry, I remember that, didn't know them. But I think CryptoKitties came out of here too. Yeah. That was Malcolm's company, right? I think. Okay. Sorry, my mistake. And here is your strategy. And the worst happens is you try and it fails. The next thing I would do is I'd find the AI to find these applications, get it to fill it out, and I'd get it to review it. I'd get another agent to review it from the point of view of a city councilor, get it to improve it, and then I would get these agents to role play until it was perfect, and then get it submitted. Pretty cool, eh? All right.
So free.
Yeah.
How much?
The max account for Claude is about $280, I think, a month. It might be higher. Don't quote me on that. They're typically around $300 a month. But look at it this way. If I hire an engineer that is this qualified, I'm paying easily $100K a year. Easy. Easy. Not to mention all the complications. Not that I don't want to hire them. But for what I'm doing personally, I find this is much more cost effective. And for the people that I do work with, the humans, I empower them with the AI. And when I do that, what I found is something amazing. They go from being great engineers to like 10x engineers. And if you look at it from that point of view, it is so worth it to use it to augment your skills. Like, look at that program that I wrote, that 400,000 lines of code. That's 9 months of work. How can one human being possibly write several 100,000 lines of code that is tested, debugged, and running? This is sophisticated code. Dask systems, complex NumPy calculations, running sophisticated libraries in pandas, and so forth. How is it possible that I could do that by hand? It wouldn't be. But using AI, I could. If I can do it, so can you. And so can everybody else. And I'm using English to program it. Now, I understand how the pieces go together, and so do most engineers. I let the AI work out the details. And there's lots of fun things you can do with AI. You know, one of my favorite things I do with AI, I'll close with this, is not only is it great to get to do your work, but it's also fun to talk to learn things. So at Christmas time, have you guys tried the voice on OpenAI? It's pretty fun, right? It's awesome. So at Christmas, they had the Santa voice. And I had Santa teaching me quantum physics. It was epic. You would get a ho, 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 and then some crazy concept and a ho, 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 ho. It was entertaining. It was driving my family nuts because they're driving back. I was in the car playing it on the speakers. And my kids did not appreciate it, but I thought it was pretty awesome. You can use it to teach you things. And it's, perhaps, yes. But the fun you can have. All right, everybody, it was a delight to be here. Good luck with your AIs. If you have any questions, please reach out to me. And if you want to do cool stuff in crypto, I'm always love to hear more about things. I think AI is the future. And I think everybody can be given superpowers. And there's a huge opportunity to train everybody on how to use it. A lot of people don't fully utilize it. It's just a chatbot. It is an operating system. If you think of it that way, and you understand how it works under the hood with embedding space and pass-through embeddings, it can do whatever you want based on whatever embeddings you create or vocabulary you create and what kind of pathways you get it to use. Yeah, superpowers for everyone.